Graphs of function. In the earlier video, we saw what are functions, what are relations, and what are sets. Now we will see how does the graph of a function look like. See, you already have this. You already have seen this type of function. First, let me write down first function. Identity function. Identity function. Identity function. Now this is fx equal to x. That is same as this x is the x is the independent variable and fx is behaving like y, and therefore y is the dependent variable. Let me write it here. Y is dependent variable. Dependent variable. Dependent variable. And x is your independent variable. Independent variable, because on the value of x, the value of y depends. Now, how to draw this type of a graph? You have this is your x-axis, this is your y-axis. Now, you can take any value of x. You can take any value of x. Suppose x I write this way and y I write this way. For x0, I'll get y0. For x1, I'll get y1. And for x minus 1, I'll get y minus 1 because y equal to x. So the line would go straight like this. This is the graph of this identity function. Now the domain of this function is the domain. Domain is completely R. That is, which can also be written as minus infinity to plus infinity. Now, of course, I have to, before I go further into this, let me introduce intervals. Let me introduce intervals. Intervals क्या होते हैं वो देखते हैं. Intervals. पहला, number 1, open interval. Open interval. Open interval. It looks like this. A comma B. That means x will not take the value A and x will not take the value B. Example. Suppose I take 2 and 3 points. This is the interval, open interval. That means x will not take the value, will be greater than 2 but less than 3. Let us draw the line here. This is my 2, this is my 3, and x will not take this value. This value won't be taken. All values in middle of this will be taken. ओपन इंटरवल का दिखाने का साइन होता है ये, और एक साइन होता है ये. ओपन इंटरवल. ओपन इंटरवल का दो तरीका होता है. देयर आर टू वेज ऑफ राइटिंग ओपन इंटरवल, दिस वे और दिस वे. इसका मतलब होता है x a की वैल्यू नहीं लेगी, b की वैल्यू नहीं लेगी, दोनों के बीच में लेगा. फॉर एग्जांपल 2 और 3 के बीच में वैल्यू लेगा. 2 नहीं लेगा, 3 नहीं लेगा. 2.00001 भी लेगा और 2.999 तक जाएगा. I mean, very near to 3 but never 3 and never 2, more than 2. That what means by open interval. An open interval is uncountable. Uncountable. And this is an open interval in which everything is between minus infinity to plus infinity. Okay, now this is one type of open interval. Now let us see the second type, the closed interval. Closed interval. Closed interval. Closed interval is like, it's always written like this, AB. That means x will take A also and take B also. For example, let me take the same example, 2, 3. Now x will be 2 and more than 2 and 3 and less than 3. Now this is 2, this is 3. Now we will take everything here between 2 and 3. क्लोज इंटरवल का सिंबल होता है ऐसे, दो स्क्वायर ब्रैकेट में. इट्स लाइक स्क्वायर ब्रैकेट विद द नंबर्स. एक्स ए भी लेगा, वैल्यू बी भी लेगा, बीच की वैल्यू भी लेगा. फॉर एग्जांपल एक्स 2 भी लेगा, 3 भी लेगा, बीच का वैल्यू भी लेगा. 2.0, 2.001 और 2.99 और 3 भी लेगा. दिस इज द डिफरेंस बिटवीन द टू, एंड दिस इज ऑल्सो अनकाउंटेबल. दिस इज ऑल्सो अनकाउंटेबल interval. Uncountable. Number of points are uncountable. Now come to this. Third, semi-open, semi-closed. Semi-open or semi-closed. Semi-closed means you can write like this: A is closed but B is open, or A is open, B is closed. This can also be written like this: A, B, this way. This and this symbol are same, and A, B closed, this and this symbol are also same. मतलब दो तरीका है सेमी ओपन और सेमी क्लोज लिखने का. यू यूज जो क्लोज्ड होगा उस तरफ स्क्वायर ब्रैकेट आएगा, जो ओपन होगा उस तरफ कॉमन ब्रैकेट आएगा. जिस तरफ क्लोज्ड ओपन ब्रैकेट है, अब यहाँ पे ए ओपन है, बी क्लोज है, मतलब ए यहाँ पे ये जो मैंने ये लिखा है, इसका मतलब होता है, let me take some space. This means this semi-closed, semi-open means in this situation means x will take the value a but will not take b. Here the situation is the value x will lie between a but equal to b. Example, let me take an example: 2 comma 3, and this is open, but x will take the value 2 and more than 2 but less than 3, never 3. Here if I write like this example, wait, the example should be this way. Example is like this: suppose I write 2 and 3, that means x won't take 2 value but will take 3 and less than 3. Okay, now this is also uncountable. This type of intervals also uncountable. Now yes, I need to tell one more thing. uh, Singleton set. Singleton set. Wait a minute, I wrote the spelling wrong. Wait a minute. Yes. Singleton set. A set containing only one element. A set containing only one element. Only one element. Only one element. One element. Element. Example, this is singleton. This is singleton. Even this is singleton. Now phi is this is not denoting an empty set. This is now some Greek alphabet phi which is inside this. Do not confuse with null. Do not confuse with null set. With null set. With null empty set, null empty set. Do not confuse. This is for all the students who didn't have maths in 11th and 12th and are studying BCA and GGSIPU. Now this is a curly bracket. Wait, let me draw this bracket again clearly. This is a curly bracket. This is also curly bracket. This is a singleton set. This is a singleton set. This is also a singleton set. This is also singleton set. But do not think that this is a null set, because a phi is, see, if you write phi, it is a null set. If you write like this, it is a null set. But if you write like this, then it is not null. Then but this, let me write it again. Let me rewrite the whole thing. This both denote null set. But this is not null set, but a singleton set, not a null set, right? Okay. Now I'll have to say something. Now see, phi can be written in terms of any interval a comma a. This is countable interval. This is a countable interval. This is the only difference, countable interval. That's why I introduced to you that singleton. Now I have two, suppose, only two. That means this is a closed interval from 2 to 2. This is also countable. This is singleton actually. Singleton set. This is also countable interval. Or other where on the top they were all uncountable. Now, now in this, let's come back to our discussion here. Let's come back to our discussion here. This discussion. The domain is an interval. That's why I wrote like this. What is the range? The range is also R. Why? R. Why? See, the domain is R and the range is R because domain भी R है, range भी R है, because you can take any value from this side on the x-axis and similarly any value on the y-axis. Any value will come on the y-axis. So the domain and range are same here. Next. Yes, we have the next graph. Number two graph. See, fx equal to x square. So the graph would be plotted as this way. This is your x-axis, this is your y-axis, and this goes like this. How did I plot? X and y. You have 0, you have 0 for y. You have 1, you have 1. For minus 1, you have plus 1. 1 minus 1 square. See, this is minus 1, this is plus 1. For 1, it is 1 here, and it is 1 here. You got 3 points. These 3 points, and then you draw the graph from here. Now this has a range domain. First we'll write domain. Domain is R. We can take any value. Domain is R. Domain is R. This now here the range is, see, the range is only the positive x-axis, only the positive real numbers. Range is positive real numbers, so we will write R plus, and 0 is also included, so union 0, singleton 0. R plus means only positive non-zero real numbers, real numbers. Now we have next graph. Next graph is third, fx equal to x cube. Now this will behave, see, one more observation in the above graph. One more observation on the above graph, this fx equal to x square. Let's see, whatever portion is on this side, the same portion is on this side. Wait a minute. Same portion is on this side. That means the graph is symmetrical about the y-axis. Let's write down this here. I didn't write it down. Graph symmetrical about y-axis. Graph symmetrical about y-axis. Graph symmetrical about y-axis. Let me rewrite it again. Graph symmetrical about y-axis. Now the next. Now this is, you can see, this will always give positive value. So this is an even function. Even function will be, this is always positive even. So this will be, rather I should say this is this way, that this is power is even. So you have both sides are always symmetrical. Y will behave like the image of a mirror. Y will behave like the mirror for this. Whatever is on the right side will be same on the left side. Now f is equal to x cube. Now let's draw this. X, wait. We have x and we have y. At 0, it is 0. At x0, y0. At x1, y1. At x minus 1, it is -1. So let's see how the graph goes. Now this is your 0, this is your +1, this is your -1. Wait, this is your -1. Now at 0 it is 0, at +1 it is somewhere here, at -1 somewhere it is here. So the graph will go like this. Graph will go like this. This is the graph of x cube. This is the graph. This is symmetrical about opposite quadrant. This and this are opposite quadrants. This is symmetrical. Whatever is on this side, the same is on this side. This side. This is symmetrical about symmetrical 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 about 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 y axis, about y, symmetrical about, sorry, symmetrical about the opposite quadrant, symmetrical about opposite quadrant, opposite quadrant. See, the first and the third quadrant, it is opposite quadrant quadrant. Now you may ask, when will I get in this second and the third and the second and the fourth quadrant? I'll tell you later on when I'll try to finish the graphs. I'll tell you when you will get in the second and the fourth quadrant. This is symmetrical about the uh, first and the third quadrant. Symmetrical about the opposite quadrant means first and third quadrant. Third, this is the first quadrant. This is the first quadrant. This is the second quadrant. This is the third quadrant, and this is the fourth quadrant. First and third quadrants. Now the next, yes, now it is the domain and the range. The domain in this case is the domain in this case is R. Domain in this case is R. Okay, R, and range is also R, because you can see all y values will be taken. It will come like this somewhere. All y values will be taken in this direction. All y values will be taken in this direction as well as in this direction. And all x values. Domain is R, and range is also, wait a minute. Range is also R. Now, these were the two graphs I made like this. Now I'll tell you if it is of 2 power, how will it look? Look, this third graph, y equal to, or fx, whatever you want to write. These are both the same way of writing the same thing. It is x to the power of 2n. Now see the graph. See, how will you plot it? First you will plot for 2, then you will plot for x. First you will plot for n equal to 1. That means, first for n equal to means x square. Now if n equal to 2, it is x to the power of 4. And n equal to 3, it means x to the power of 6. Like this. Then you will plot the graph in this manner. You will plot the graph. You will plot the graph the way I did here. Exactly like this, you will plot the graph. You will plot the graph like this. I will no more do like this. I did it for 1 or 2. Now you will straight come to results. You will straight come to very important results. Now, in this case, the graph will look like this. The graph will look like this. This is your x-axis. This is your x-axis. This is your y-axis. This was your x square graph. This was your x square graph. Now, in order to draw the x4 graph, it will be like this. This is the x4 graph. x4, x to the power of 4. X to the power of 4. Now we will draw the other graph, that is x to the power of 6, something like this. This is x to the power of 6. This is the way you will draw the graphs. Now this is this, of course here also the range is, the domain is R. Domain is R, and range is R plus, but all positive real number union, because 0 is also here. So it will take the word 0 and like this. The range is this for this graph. Now let us see. Now let us see this fourth one. We will see the fourth one. That is, fourth one is, we have a y equal to fx equal to x to the power of 2n minus 1, or in some books that means when n is 1, That means y is equal to x cube, because 2 into 1 sorry, this will be y equal to x. When n equal to 2, y equal to x. 2 into 2 minus 1, that is y equal to, sorry, x equal to x to the power of 4 minus 1, and that is nothing but x cube type of graph. And you have n equal to 3, you have y equal to x to the power of 6 minus 1, that is x to the power of 5, and so on and so forth. Now, how to draw this graph? See, I have already shown you the cubic graph in above. Now we will draw this x y coordinate, we will draw the x coordinate. Our the cubic graph is going like this. You have already seen, you have seen the graph go like this. This is the cubic graph. This is the cubic graph. This is the cubic graph. And now you will see x to the power of 5 graph. See how to draw x to the power of 5 graph. See, x to the power of 5 graph is something like this. It will start from here, it will go little here, turn little here, and then it will turn and cross it here like this. A little bit of adjustment I need to give you. Wait, let me do it again. This will go like this, it will come like this, come, and it will go like this. Again, I made a mistake somewhere here. In this turn, I made a mistake. Wait, my drawing is not that good, but still I'm trying to make it. Yes, now it is okay. This will be x to the power of 5. Now x to the power of 7 will start. Let us see, x to the power of 7 will start like this, may go like this. This will come down than this. And oh, wait. It will come like this. It will go, wait, x to the power of 7 graph will be going like this a little bit, and it will go down a little bit, and it will be this type of a graph, x to the power of 7 graph. This is yellow color is x to the power of 7. Odd powers, all the odd powers. X to the power of 7. Now we will have, we did, I told you about x to the power of n this. Now we will talk about the other one. Now we will talk about a next graph. The next graph is y equal to fx. I think this is the, let me see which it is. Just a minute, another number. I'm talking about the number of the graph. This is, I think, 4, 3, 4. Yeah, we will be doing the fifth one right now. We will be doing the fifth one. Here 5 it is 5 here, and y is equal to fx is equal to x to the power of, sorry, 1 upon x. 1 upon x. Here, see one thing, the graph will be symmetrical about the first and the second quadrant. It will be like this, and it will be like this. This is for x to the power of 1 upon n. The domain and range, see, at 0 it will be infinity, right? And little bit of right side of 0, it will be also be going towards infinity, minus infinity. And this will be on the right, this is the left side of 0, this is the right side of 0. It will go to infinity. Wait, it will go to infinity. On the right side of 0, it will go to infinity, and the left side of 0, it is going to infinity. So therefore, the domain of this graph is r minus, you will remove only 1.0, and the range is also the same. The range is also r to, you will also have the same range. It is symmetrical about the opposite quadrant. It is symmetrical about the opposite quadrant. Symmetrical. This is the first quadrant, and this is the third quadrant. This is symmetrical symmetrical about the first and third quadrant. It will be symmetrical about the first and the third quadrant. Now this is done. Now we will see for x square. This is for odd power of 1 upon x. This was odd power of 1 upon x, x to the power of 1, something like that. Now let us see for here. This is the 5th, 6th, 7th. I think 7th. Yeah. Wait a minute. 5th, 6th. Okay, 6th it is. Now we are doing the 6th one. We are doing the 6th one right now. Wait. Yes, we are doing 6th one. 6th one is y equal to fx 1 upon x square. Now this will be symmetrical about the y-axis. This will be symmetrical, symmetrical about the y-axis, why? Because of the square term. Now you see, wait, let me rub this. Okay, now you see this way, the graph is like this, and the graph is somewhat like this. This is your x-axis and this is your y-axis. It will come like this something, this will come like this something, this will come like this something. Now the thing is this, you may those suppose I ask you, suppose I think I've told you in physics, in my physics lectures, that the force of attraction is inversely proportional to r square. I've told you this law of gravitation as well as electrostatic law. F is inversely proportional, the function f is inversely proportional to r square. It will behave same as this x square. So in that case, I will draw only the positive part. I will draw only the positive part. I will not draw then this negative part. So I have your F, the four gravitation or your electrostat, and I'll draw R, and I'll get a graph like this. In this thing I've seen in which, in your gravitational force of attraction, this type of result, and as well as the electrostatic force of forces, we have seen this. They obey inverse square law. For inverse square law, the graph is going to be this. The graph is going to be this. Now, suppose I want to make some change in this. Okay, before I go into more details, let me tell you about the range and the domain of this graph. See, the range is the domain is other than zero, everything is in the domain. In domain, you have r minus 0, and in the range only you have the positive part of the y-axis from 0 to infinity. The positive part of the from 0 to infinity, the positive part of the y-axis. The range is an interval which does not contain 0, does not contain infinity, and everything.